All right, good evening, everybody. So tonight we're going to be looking at getting the AC input power connected to our Victron 5 kVA inverters. So tonight's the night that we finally get the last big piece of wiring done with these inverters. The final components finally showed up, and I'll just be happy to have the wiring done. When you don't have AC in, now you're really having to really pay attention to, all right, do we have enough sun coming in? Are the batteries getting recharged? And it'll be nice to be able to just have that set and not have to worry about it anymore. So we're going to look at getting all of that buttoned up, and then depending on time, we might dive into the software to program the MultiPlus inverters as well. Because I have a feeling we're going to end up having to use the software to make some changes on how the AC input is used. So let's get started. I'm going to do something that I saw on, I believe it was Engineer 775's channel, and I want to say it's called a line side tap. So I'll show you what I'm doing. So here's my transfer switch. I've got my AC in coming down in the top here, and then down here on the bottom is my AC out. So what my plan is, I'm going to put Morris connectors on these connections here and split them. So I would have one line coming down into the top of the transfer switch, and then the other one's coming down into the trough and then going up to the inverters. Now, the reason I'm doing that is because if this transfer switch is ever in the grid-only position to where grid is supplying power, the inverters aren't going to be using and outputting power from the grid anyways. So it's really, this transfer switch is making it so that the grid in power is only ever going to go to the transfer switch, or it's going to go around the transfer switch and down to the inverters. Now, again, I am not a licensed electrician, so don't take what I'm saying as gospel truth. And then the other thing, because this is a pass-through neutral, all the neutrals are all connected as a common neutral here. I'm just going to split down here for my AC input. If I actually had a 5-way, I'd probably just do a 5-way, because it's all a common neutral anyways, because this is a 2-phase switching transfer switch, not a 3-phase switching. And I showed you this earlier, but one big plus about these inverters is they actually give you a wiring diagram of how the AC in and AC out are connected together. So you can see on the left, AC output, there's no breaking. AC out 2, there's a relay on the line side. And then AC in, there are relays on the neutral and the line. So when AC in is supposed to be on, it will close the neutral and the line, and that becomes a common neutral. And then the line is connected to the line for AC1 and AC2 out. So let's get started. Let's get some AC in power. And then I believe I'll have to figure out how to program the inverters. Because these inverters are typically designed, I believe, for like the mobile and the marine applications, to where if you've got AC in coming in, that's what wants to be the priority. So think of this as from the RV standpoint. You're driving around in your RV, you're running off battery power, no problem at all. But then you pull into your camping spot, and then you plug into shore power. Well, when you plug into shore power, you want to use that shore power. So these units will default to the grid connection, and then they'll start charging your batteries and that kind of stuff. So I'm assuming that the way this is set up by default is as soon as I turn on these inverters and I switch on the AC input power, these inverters are going to start charging the batteries from grid power. So I'll have to figure out how to turn that off and change it so that the inverters fall back to the grid only at a specific state of charge. But I don't know how that's supposed to get done yet. So we'll have to figure that one out together. Try to get somewhat of an angle so that I can still work and you can still see. Safety first. 123 millivolts, 41 millivolts, 50 millivolts, and 8 millivolts. So this panel is dead. Inverters are turned off. So we have no potential for power in here. So no zaps, because we don't want those. I swear, people, you're gonna freak me out. Every time I'm working in some electrical panel, somebody's sending me text messages, which is causing phones to vibrate and everything. And it always happens when my fingers are right inside there. Knock it off. I'm already on edge thinking that I forgot to turn something off. Stop sending me messages. Fortunately, I don't have a whole lot of room to work in here. Oh. So I had already gone through and pre-cut my AC lines to length. So let's see here. The far left is AC out, middle is AC out 2, so the right one is AC in. So I need to be into the right conduit. And the order of cabling is the same on all three. Neutral, ground, line. So we want our black line up in to go onto the far right. Snug it up. And we got the same here on our phase 2 inverter. So then we'll feed both of these in and it'll come up this conduit here. And that was a pain. So we'll pull these up and in, and hopefully I have enough on this red. I was not planning on having to go all the way over there. Well, let's get the black done first, and then I'll have to look at the red. So unfortunately, it doesn't look like I have a cable long enough for the red, because I was expecting it to be over here, but then there's not enough room over here for the red to be over here. So that's kind of annoying. So what I'm going to have to do is I'll cut the red down in here and I'll have to extend it. Not as clean as I wanted it to be. It would probably be a whole lot cleaner if I had a 200 amp transfer switch, but it should still work. So I wish I had the straight through ones, but I don't. I've got a double, so it'll come in one and out the other. Whether or not this part is right, I couldn't tell you. Actually, I can tell you I just screwed up. In order to have 2 more outputs, I'd have to have a 4. 1 in, this one out, and then 2 more out. All right, so you saw I screwed up. I did not have the right connector. So what I ended up doing, I'm going to put a 2 like this one to connect these back together, because you're not allowed to have 2 wires going into the same port. Even on the opposite side, you're not allowed to have that. It's one per. So I'll reconnect these with a 2, and then I fed in a separate line coming off of the neutral bar over here. I did not want to do that because I wanted to keep the neutral split connection over here as close as possible, but it's what I had to end up doing. It's either that or I ended up buying another splitter. And unfortunately, I don't believe I have enough wire of white to redo this straight line, so for the time being I will just put a connector here. I've got plenty of these floating around. And then off of this new line that I pulled, then I will put this on, split it off, and send my AC in neutrals up to the inverters. Not what I wanted to do. Really not what I wanted to do, but stuff happens. This AC input connection stuff was not supposed to take this long. And it looks like I am out of all my longer white wire. Bah! So for the time being, I'm going to reuse my black. I'm just going to put some blue tape on it to differentiate. I will get white tape later. But at least this way I can complete this. I do not like it. I don't like using the wrong color. But you use what you gotta use, right? So I will come back through and I will either zip tie or tape, probably zip tie, because zip ties will look better. Zip tie all these together so that I know which ones are AC ins and AC outs. But you can see I fixed my screw up here. So this is our AC out. And then our AC in, I ran a new AC in line. Unfortunately, I ran out of white wire and I don't have white tape. So I've got black wire with blue tape coming up to both of these. And then the ground in these is all bonded together. So I can run a ground line from here down to my bus bar if I have to. But if they're all grounded together, I don't know that I really need to. Because if I add multiple points, yes, it's a short run, but you've got multiple points going to, you could create a ground loop, couldn't you? And then up in here, we've got our tap. Everything's nice and tight. And then over here, our rat's nest. So I guess we turn things on and see what happens. So I think the big thing to do first is to turn on the AC input feed. And just make sure we've got everything here at each of the inverters as well. And then we'll find out, actually, because I know the 6500s would turn on when they had AC input power, even if they were off. They'd go into like standby charging or something. Because these inverters actually have a physical on and off switch, they shouldn't do anything even with the AC input coming in. So let's find out. So breaker was flipped. No sounds, no noises, no nothing. We will very carefully, 240 volts, 120, 120, 120 volts here, 120 volts here. It's interesting. I actually hear a sound now. It's almost like the transformer or something. It has a very quiet sound with AC input. We turn the AC input off and just see if we hear the sound. Nope. So it's only when you've got the AC input there. Yep, it's back. Okay. So let's turn the inverters on and see what happens. My guess is it's going to start trying to charge automatically because it detects shore power, grid power. So let's see, 3, 2, 1, contact. Boy, that's a big old jump. Holy cow. Scares the living daylights out of you. So it is trying to charge with 60 amps. Wow. Yeah, that, another thing that makes you just jump. So I just dropped it down to 10. But again, I don't want it to charge every time it detects AC input power. So what I'm going to have to do is I'm going to have to go into the settings of the inverters and see if I can stop it from doing that. I believe I can hit inverter only. There we go. Okay, so it's only inverting right now with everything still connected. So yeah, I'll have to go into the settings and figure out exactly how to program it to only charge when it gets below a certain threshold. And when I figure it out, I'll take you with me and show you how I did it. Because that's one of those things that you click, 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 click. Nope, 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 nope. But we've got AC input power. We know it works. We know that when it charges from AC input power, boy, it's got a big old clunk and it's going to make you jump if you're not ready for it. So let's get everything closed back up. Get the house back on inverter power, and then I'll look at some of those settings. Well, time got away from me, and unfortunately, I didn't get nearly as far as I wanted to. I wanted to be able to actually include in this part of the video how to program the MultiPluses to kind of ignore the AC input. I want to do a video on my initial first looks of the programming software for the MultiPluses as a whole, but then I'll probably include into that, because I don't think it's going to be that difficult, but I'll include in that video as well how to set basically the units to ignore AC input power until you get to a certain threshold. But ultimately, I'm glad that, the majority of the wiring's done. I still have yet to do some cable management and stuff like that, but it's hooked up and it's running. Yes! I will say that those relay clicking if you're not paying attention, boy, when that clicks, you jump. I have a feeling that it has something to do with the fact that there's so much open space inside these inverters that when the relays click, the sound just kind of resonates inside those inverters. And then the fact that you've got two of them stacked side by side and they're both doing it at the same time, it really makes you jump. But for the most part, you're probably going to be putting these in places you're not going to be hearing that anyways. I know in my case, I might hear it in my office, maybe. Well, let's see here. So coming up, the next couple of things that I have on deck, I've actually started editing all of these, is I have a video on the servo installation and configuring the VRM. I've got another one that I said I wanted to do on the MultiPlus software. And then the last one, I want to do a look at the Victron 450-100 charge controller and give you a little bit of a look at that. Because I haven't really talked much about that because it hasn't been a part of the 10 kVA kit that I received. It's kind of a separate thing. But it's still a great charge controller that I want to talk about as well. And then after we get done with those 3 videos, I think, then we start getting into the meat of the stuff that you guys are really wanting to know. How's it going to work? Can it supply power to A, B, and C, X, Y, and Z? What's the sound like? I've gotten so many questions from people on what's the sound like. So don't worry, I'm going to be doing a video on that one too. But I'm going to try and get these next 3 out pretty quickly so then we can jump on into some more of the fun stuff. So with that, I'm going to let y'all go. Y'all stay safe, stay cool, and we'll catch up with you later.